Good evening everyone. Now in this session of our class I am going to explain theorem 9.1 related to standard 9. What does the theorem say? As you can see the figure itself, it states that we have to prove that the parallelograms on the same base. If you see here, there are two parallelograms here. Number one, the parallelogram is A, B, C and D. Okay, and the other parallelogram is E, F, C and D. Now what do we have to prove here? We have to prove that these two parallelograms which lie on the same base and between the same parallels, they are equal in area. Okay. So the first step that we are going to write, we will write that given. What is given to us? We are given parallelogram A, B, C and D and E, F, C and D. After that, we will mention to prove. What do we have to prove according to this? We have to prove that they are equal in area. So we'll write the symbol for area. Area of parallelogram ABCD is equal to area of parallelogram EFCD. Okay, this is what. Now let's begin the proof of it. So we'll start with this proof. Now we'll begin with these two triangles at the end. Triangle ADE and triangle BCF. So we'll write here in triangle ADE and triangle BCF. We'll prove these two triangles congruent first. Alright. So first what do we see? We find that the line AD is parallel to line BC. Second thing, the line DE is parallel to line CF. Now in smaller classes you have learned about the angles between the angles on the same side of parallels. If you see here, they are corresponding angles. See, this angle is corresponding to that. This angle is corresponding to that angle. As you can see, you learned this in class 8 when you were going through the concept of transversal parallel lines. Alright, so first to prove this, we will write angle EAD, that is equal to angle, as you can see, angle EAD. Now which other angle is corresponding? FBC. So you write angle FBC. Here we will write corresponding angles. Alright. Now the second thing we see is, what do we see here? We find that the side is parallel. Which two sides are parallel here? AD is parallel to BC. Side AC is parallel to BC. As you can see. Alright. So we will not write it here. We will just leave it alone from here. Now we take the second angle. Which two angles now? Angle AED. If you see here, angle AED is equal to the other corresponding angle that side, BFC. So write it down. BFC. Even these two angles are corresponding angles, as these angles are on the same side of parallels. Okay. Right. As you can see, the second line also, DE is parallel to CF. Right. Now what do we see here? This line AD and the other line BC. These two are equal. Why? Because they are opposite sides of the parallelogram. What is the parallelogram here? A, B, C and D. So we will write AD is parallel to, or AD is equal to BC. You will write sides opposite sides of parallelogram ABCD. Okay, so with these three proofs, we have found that these two triangles are congruent. Which two triangles? Therefore, triangle ADE is congruent to triangle BCF. Hence, we have proved that these two triangles are congruent. Now, once we have done this, it means as these are congruent, also therefore, after this you write area of triangle ADE is equal to area of triangle BCF. One second. BCD AD is equal to BCF. Alright. So now having proved that the area of these two triangles are equal, now what do we see? In parallelogram ABCD, if you see this A, B, C and D, what do you see here? You see a triangle plus you also see this portion. So we'll write here area of parallelogram ABCD is equal to, that will be equal to area of triangle ADE. See this, ADE, area of triangle ADE plus, do you see anything else here? ADE, the parallelogram lies from here till there. Do we see any other figure? Yes, we see E, D, B and C. We see that? So we'll write EDCB plus area of E, D, C and B. Now what do we find? What do we see here? That these two triangles are congruent. If these two triangles are congruent, it means the areas of both these triangles are same. So when they have the same value, we can replace this value as area of BCF plus area of, see this, area of BCF plus area of EDBC, EDCB. Now what have we done? We have taken the area of this plus area of that. So we see that the parallelogram has changed. The parallelogram is, which one is this? E, F, C and D. E, F, C and D. The area of that parallelogram is equal to area of that triangle plus area of this section. So we'll write is equal to area of E, F, C and D. So what have we proved here? We have proved that parallelograms on the same base. Which two parallelograms are there? You can see here ABCD, ABCD, and the other parallelogram is EFCD. These two parallelograms, they lie on the same base and between the same parallels. Hence, it's done here.